compared to the other. Okay? So, that's a redox reaction because if we write out all of the charges, we can see charges change. Okay? So, most of you could balance this out without doing it this way, but I'm going to show you this way because there's some that are impossible to balance unless you figure out how to balance out the electrons first. So you're like, well, what do you mean? How do you balance out electrons? Well, you kind of know where they're going and you know where they're coming from. So we have this thing called redox and oxidation reduction. So oxidation is a process of losing electrons. So something that has oxidation loses electrons. Okay? And reduction is a process of gaining electrons. So we come up with this, it's a real, acronym that allows you to kind of determine what's happening. It's called oil rig. So what do you think oil stands for? Oxidation is losing. Reduction is gaining. Oil rig. Okay. Now there are some students that will mess this up because they think something that loses will be a negative charge. That's not the case.
But positive.
Be a positive.
Because then there's more protons in there.
Right. So anything that loses electrons will be positively charged. So there's this common knowledge that, if you leave iron outside in the elements, and if you got an older vehicle, you can kind of see some of this happening. There's some rusting that will take place. And that's called oxidation, because when iron rusts, it goes from 0 to a positive 3 in this case. And look, it's being oxidized. So when we say things are oxidized, what they're doing is they're losing electrons. And what do they lose electrons to? Well, a lot of times it's oxygen in the air. Okay? A lot of times it's oxygen in the air. All right? So on the top, look at which, go ahead and identify on both of those. Identify the element that's oxidized and identify the element that's reduced. Get an iron ring, like those up here. What they would look like. Yep. And then when you grab this, a lot of people grab it like this.
Okay.
Grab it like this. Yes, a lot more control. Okay. And then you just have to heat it for, like a minute. And you cut that in small pieces. Alright, so on this first one, aluminum is oxidized. And hydrogen is reduced. So every time you got a reaction, something has to be oxidized. Something's got to give up electrons, something has to bring them in. So, like on the bottom one, you'd have iron's oxidized. And oxygen is reduced. Okay, so we'll just start off with some simple one balancing, and you can kind of see how the electrons are change hands between one thing and another item. The thing with electrons, you have to have equal number of electrons lost and gained. So when you balance these reactions that are really tough, I'm going to give you here in about 10 minutes. The first thing you do is you have to decide what's happening to the electrons. Okay. So on this first one, what's happening to the electrons on this first one? Tell me where they're going, where they're coming from, how many's lost, how many's gained. So where are they coming from? Where are the electrons coming from that are being transferred? What element's giving them up? Al's giving them up. Right?
Oh, yeah.
How many do they give up?
3.
3. For every one of those that go from the left side to the right side, every atom that goes from the left side to the right side, they lose, or they lost 3 electrons in that case. They lost. Well, they have to be gained somewhere. You can't just lose electrons without them going somewhere. Finding a spot. So what spot do they find?
Hydrogen?
Hydrogen. Hydrogen says, I'll take them. I'll take them off your hands. Aluminum, you've got them to give. I'll take them. Okay? So hydrogen takes them. I like to kind of divide them off. I like to put one line above, one below. You guys will have a little bit more room above yours than I do. So how many, for every hydrogen that moves from the left side to the right side, how many is, how many's gained?
1.
Gained 1 electron. Everybody see that?
Yeah.
Okay. So when we say how many's lost and gained, we're saying for every 1. Well, you're going to have to find a way to balance out the number of electrons lost and gained. So you can say, well, I can get 3 hydrogens, right? If I get 3 hydrogen, that equals the 3 electrons. You guys see that? If I get 3 hydrogens to go from here to over here, then I'll get my 3. But there's a problem with 3. 3 is not going to work, right? Because if I put a 3 in front of this, to show those 3 hydrogens going, I cannot put a 3 in, I can't get a 3 by putting a whole number in front of H2. So you're going to have a multiple. So if it's not 3 that you can work with, what's the next multiple that you can use? 6. So what we would do instead is you say, okay, it can't be, in this scenario, it cannot be 3. It's got to be multiples of 3. So I can have now 2 aluminums. Let's say I have 2 aluminums go. So that would be a 2 out in front here. So then that multiplies by 2, and that gives me 6. Then over here, I would have to show 6 of these going from the left side to the right side. And so that would make a 3 in front of H2, and then in front of Al, it'll be a 2. And that's balanced, right? Now, it would be a lot easier to balance if I didn't show you that method there. Okay? But I guarantee you there's going to be some, we'll do one in class and then have you guys kind of practice and mess around with the others. Because like I said, they're kind of like Sudoku. I don't like Sudoku. Okay? Because it's like you have to, get numbers in 1 through 9, right? And then you got your 9 quadrants. And then you have to go through and figure out you have 1 through 9 in a quadrant, and you got 1 through 9, right? This is kind of like that. You kind of like, these are solids. You know, when I say what I mean by solid, the 2 is a solid here. You can't ever change that number. The 6 is a solid there, and then when you go to put numbers on the other side, then you know what to put in. So when I say solid, I mean you're not ever going to go back and change them. You're not going to go back and change them. All right. Now this one, this one's really easy too, the bottom one. And we would just go ahead and do the same thing. We'd say, well, iron's oxidized. It goes from here to here. And then oxygen is reduced. It goes from here to here. For every 1 iron it goes over, that is lost 3 electrons, just kind of like above. And then for every oxygen that goes over, it's gaining 2 electrons, right?
Yeah.
So what's the common number of electrons we can maybe work with at the beginning? So 6. Okay, so if I put a 2 here, that would give me 6 electrons, right? Okay, can I put anything in front of this here to get, I'd have to put a 3 here, right?
Yeah.
Okay, so if I put a 3 there, then I'd have to put a 2 in front of this one.
Yep.
That doesn't work for the.
But that's 4.
Yeah.
Okay, so how many oxygens actually are moving? 6 of them. So I times this by 6. What do I get? 6 times 2 is 12. And I take this times 4, and what do I get? 12.
Say what?
Right?
What do you take times 12?
Well, this should be a 4 out in front here now. So now they balance. So the 2 wouldn't work. Okay, the 2 wasn't going to work to show the number of electrons. Because I'd had an odd number on the right side and it would have worked out. So, okay. What I'm going to do is I'm going to give you a sheet, and then we're going to work through a problem together. So on your worksheet, you got number 1, and you were asked to go through and find all your charges. Now, if a guy would try to balance this first, look at all the oxygens and all the different locations oxygen are. I mean, you're just kind of battling, and it's just become really difficult when you've got hydrogens the same way. You know, it's just messy looking. It's like, I don't want to balance this, but you have to. And so then what you do is you go, okay, I'm going to go ahead and find all the charges. So this is plus 4 minus 2, plus 4 minus 2. The only way it works is if you guys get the charges right. If you don't get the charges right, it doesn't work. Okay, oxygen's a minus 2. I probably shouldn't even show oxygen because it's like so repetitive. I'm going to.
So for NO3, you don't put plus or minus 1. It's
Right, you gotta have everything. So what happens? You got NO3, and remember, Friday we made that equal to a minus 1. So this is a minus 6 total. I'm just doing the total. So then nitrogen has to be a plus 5. So I just split it off. You can do it with it in there too. That one would probably be pretty simple to do it within it. Nitrogen is the only one you have to solve for. So this would be a plus 2, plus 5, minus 2, plus 1, plus 7, minus 2, plus 1, minus 2. Okay, is there any there that you got questions on how I solve? So I guess you're doing 2 things here. You're really it's making you practice to know how to find their charges or their oxidation states. So it's really good because within that whole thing, I had 6 problems I could solve, and their oxidation numbers. So it gives you a lot of good background on that. So then you apply what we just learned. Which element's being oxidized? Mn. Manganese is going from a plus 4 to a plus 7. So it's losing 3, right? Lost 3 electrons. Okay, what's being reduced? PB. PB is going from here to here, and so it is gaining 2 electrons for each one, right?
Yeah.
Alright, so then the very first thing you do to balance these is you get the electrons to balance. So go ahead and see what you need to put in front of, hey, just figure out what you have to put in front of the left side first. I think it's good just to realize how many has to go from the left to the right. Because they could go to multiple spots on the right side, which makes it even more difficult. So the best thing to do is just figure out what number of leads and what number of magnesiums I have to go from the left to the right and see if it's going to work out. How many manganese are we talking about? 2. We have to have 2.
We have to meet that.
And then lead we have to have 3. Is that right? Is that what you guys have?
Yep.
Okay, so then what you do, you get that point, make sure that those numbers work. Which means if you put them on the left side, can you put them on the right side to balance them out? So if I put a 2 in front of manganese, can I put a 2 in front of HMNO4 and they balance out? And the answer is yes. The manganese will balance out. I put a 2 there, and a 2 there, and the manganese balance out, right?
Yes.
Then I want to see if lead works. So will lead work if I put a 3 in front of both?
I think so.
Put a 3 here, 3 leads. Put a 3 there, 3 leads. We're good to go. Now, since we've got the electrons to balance with those numbers, we only have 2 slots we need to fill, kind of like Sudoku. We got 2 slots we need to fill. Okay, so the question is, which one will you balance, H, N, or O first? What do you think would probably be the best one to try to balance of those 3 in H, N, and O3? Would you balance H?
No.
I wouldn't. H is in 2 spots, and we have 1 spot we don't even have a number for. How about N?
Yeah, probably.
Yeah, because N only has 1 spot, and that 3 is solid. It does not, will never change. So how many nitrogens do you have on the right side?
6.
6. 2 nitrogen, 3 out in front, makes it 6. So what would you put in front of HNO3?
6.
A 6. So the nitrogens balance. Which one would you go to next? Well, hydrogens and oxygens are going to be maybe H, because
Maybe hydrogen.
I don't know, yeah.
Because
That's
there's only 2.
right, and then this nitrate has an N in it. So let's go with hydrogen. So on the left side we have how many hydrogens?
We have 6.
On the right side, how many do we have?
4.
4.
We have a 2 in front of this one.
Yeah.
And we're not going to change that number. So to get our total of 6, what do we have to put in front of water?
A 2.
A 2. Now we have
So then
2, we got 4 here, and we got 2 here,
So that's 6.
that's 6. So that balances. Now oxygen should balance.
Hopefully.
So then you just count your oxygens and you hope they balance. Now, yeah, just count them up. Cross your fingers. See if they balance. So on the left side we got 4, and we've got 6, and we've got 18, right? 18 in the HNO3, 6 in the O2, and 2 and 4 there. So that's a total of 28. On the right side, do we have 28?
Mm-hmm.
We do? 2 times 3 is 6. 3 times 6 is 18 here. There we got 8.
Oh no.
And there we got 2.
Uh-oh.
So 28 and 28.
Oh.
Right?
Yeah.
Okay.
I definitely did my math right. I was like, oh no, this doesn't.
So you got to be able to count multiple spots, add them together. Okay?
Okay.
And it's just a work in progress. It's this part gives you basically a head start, and it tells you these numbers, if I put them in front and bounce out my electrons, I can't change those numbers again. So, in this example, I could not change the 2, I could not change the 3, I could not change this 3, and I could not change that 2. So then all I have to do is get the other 2 slots. And I get my answer. So, we'll do the next one together, and then at least I'll give you the charges and then see if you can balance it. So, I'm just going to give you the charges, and you guys can continue to work on that. So, it's plus 1, plus 7, minus 2, plus 1, minus 2, plus 1, minus 1, plus 1, minus 1, plus 2, minus 1, plus 1, minus 2, 0. Okay, so then you can practice doing that one.
To find the charges of like the Cl and the salt, like for like the HCl and like the H2S.
Yeah.
So do you just look at the charges on your periodic table?
Yeah. Yeah. For the most part, yeah. Yeah. Your H, I don't know. It's very rare that it's going to be a negative 1. It could be a negative 1 if it's with a metal. And oxygen is pretty much, oxygen is always going to be a minus 2. Then your metals, when you look them up, they could have multiple charges, so you use your other anions to find them, and that allows you to find them. So why don't you go ahead, see if you can balance out that one, and then I'll go through the answer on that second one.
God bless that. I do that way too much. It's not a good thing.
So that was lost 2 electrons and gained 5 electrons, and then we put a 2 and multiply both these by 2, 5. So 2 and 2 and 5, 5. And then you just got to fill in the rest, right? Which one did you guys decide you thought would be best to fill in? KCl, HCl, or H2O?
I did KCl.
I would do KCl because this 2 in front of the K, even though 4
It's the only K.
is the only K. Yeah, so you look for those that are definite. So then chlorine is probably the next one you could go to,
Yeah.
right? And then on the right side you have 6. So over here you put a 6. And then is H2, we only have one H2, so that'd be a 3. Is that right?
No.
No?
Yes, maybe.
Wait.
That's not what I got. But
Okay, where did I go wrong? Let me go back and erase this 3.
because on. Okay. What are we on right now? H's?
CLs, on the right side I have 6. I only have one place for HCLs over here, so that would be 6
Yep,
HCl.
I got that. But then I didn't get 3 on the hydrogen. Because,
There's 2 slots.
Oh, there's
The
2
left side.
slots.
yeah.
So it'd be 16, so it'd be an 8.
Yep,
Is
that's
it right? Okay. I didn't see the 10, so that would be 8.
Yeah.
Would oxygen be easier to go to?
Maybe.
I think oxygen would have been the easier one, because it's only one spot here.
I've checked.
So 2 times 4 is 8. That would have been the easiest one to do,
Yeah.
because you only have one spot on both sides of oxygen in that. So, all right, there you go. Now have fun.
So, are we turning this in?
3, 4, and 5 just do for tomorrow, and we'll see how good a job you guys did on that.
Perfect.
Number 4 looks like a tough one.
Oh, don't tell me that.
I don't know. It just looks like a tough one. It's probably really easy.